Yes, and I will put. So we are going to speak about microcontroller programming. So here you can see we will speak about these microcontrollers, but we will speak about Arduino, basically how we can program it and what we can do with there. But before we do this, I wanted to ask you, do you know what is a microcontroller? So if we just write here microcontroller, uh, so yeah, if you take some pictures, then you can see that these are the small micro scheme or the microchip, and there are so different things of them. And those microcontrollers, these are small computers or small processors. And if you want to understand how they work, we need to. Well, there is a good simulation which is called Wokwi. You can also use this website. I will just send here, and you can do it together with me, so that you can try yourself as a person who programs like different things with the microcontroller. Before we start operating these things, I want you to tell more. I want you to tell me more about this Arduino board. So basically, if we just click it, we can just go to official website, arduino.cc, and it is an Italian product which allows you to experiment with different microcontrollers and use them like real ones in the internet. If you like these things, you can even buy yourself a starter kit and try to experiment yourself like without any problems. But here, if we just move to documentation or to products, you can see there are so many different ones. We need to have Arduino Uno. So this is the board which you can have, and we can try to take this part, and I will explain what is inside there. So here you can see this is like the board. Let me. Oh, this is like a simple one, but maybe we can try to take another one. So Uno family board, and you can say here, for example, Arduino Uno R4 minima, and here we have actually that could be with Wi-Fi, and this is this one. I will take R3. So this is the usual board I have worked with. So you can see that here we have a microcontroller itself. This is the microprocessor which does all the things. This is basically the computer. Here is the motherboard, and here you can see that this is these are the pins to which you can connect your devices, and you can program each single pin. And in order to here you have some kind of special pins like voltage, and here you have analog pins. So let's just try to understand how this works. And if you can see, when you go to the simulator, when you choose Arduino Uno, you can see it's there. There are already many projects which are prepared, but we will take the empty one, Arduino Uno, and you can see that here you have the same board. You have the same board, and here you have the programming code. So in this board, you have all these pins, where you can connect devices. Here you have the USB Docker USB connection, which allows you to connect this device to computer and to upload program to this microcontroller. Because initially, if you do it in real life, then you write a code on your computer, on your laptop or your desktop PC, and then this code shall be transferred to the board. And that's why you connect it via USB, then press upload, and this code is taken to the memory of the board. After this, you can disconnect this and you can connect it to the power so that it is possible to operate. And as soon as it is connected to the power, then the code which is written into the microcontroller will be started execution will start executing in loop. And here is the button to reset the board in case it is like something went wrong. You can reset it and start from scratch. So now we need to understand here how to write the code, but it is not interesting to write the code without any kind of devices. So here, if we press plus, we can insert different devices to the board. In the simulator, of course, there is not so many devices, but still there are lots of. You can see there is a lot of devices that you can connect to that guy. And you can see even logic gates you have there. And here you have the first one is LED. So you can do like this. In case, actually, you can follow me and you can try to do the same parallel with me. So just open this website, um, find the board Uno and have it like this. You see here, I can choose the color of the. So if I choose the color of the board, and I can change, for example, the color, and I can close it. So this is like that. And now you can see that this LED lamp, it is not connected to the board, but we can increase it. And you see now we can connect. So if you have the lamp, you can also read documentation on the lamp. You can put the question mark here, and you can see here is the small reference what is about this board. So you can see this is a standard LED, and you have two of the things. You have anode and cathode. So anode is a positive pin and cathode is a negative pin. If you come here to that board, you can get here, you can see this is the C, it is basically the cathode, and you can have A, which is anode. So this is a positive pin and this is a negative pin. In lamps, in LED lamps, it is important that you connect the pins correctly because you know that it is a light emitting diode, and this diode will never operate if you connect the polarity in the wrong way. So this should be always to the negative part, and this always should be to the positive part. How to connect it? You can see that these are the digital pins, and this is the ground. Ground is always for connection to the negative pin. So you can start connecting the ground, and you can see that it goes here, or you can connect also, for example, to here. So, but you need to connect it to the place exactly to the pin here. So you have connected ground to the pin, and now you have to choose one of these 13 pins in order to connect to A. So here you can try to connect it, for example, to the pin number 11. So now the LED is connected, and you basically can move it where you want, but the connection will not be lost. So connection is done. And now if you want to start simulation, you can start, you can add power to this place, and you can see here is the software, the program code you can upload to that microcontroller. If you just run this simulation, you can see that the LED is not shining because the microcontroller doesn't know that it needs to give some voltage to these pins. And if we want to have it shine, then we need to give a voltage to that pin. So first of all, in the here, so this language, programming language, is very similar to C++. So if you know C++, then it is quite easy to understand the programming language. But believe me, it is really simple. So here we can have a definition of the pin mode. So we can say the pin mode. So here, pin mode, and you can have it like this. Pin mode. Let me take 11. So I will take here 11 and comma. And you see, I have to insert what is this. It is input, input pull up, or output. So here we need to choose output because this pin is working for output. It doesn't require any input, but it requires output. And now we know that this pin will await, will receive some signal from the microcontroller because it is output. And so it means that it will receive voltage, and if it receives voltage, then the lamp will shine. In order to make it shine, we need to create now digital write. Digital write, it is a special procedure. And then we have to say here the pin 11, in the pin 11, and then we can say higher or low. You know what is the difference between them? Higher signal stands for 1 and low for 0. So we need to make higher, and it means that now we are going to shine the lamp. So now you see I make it so that I'll just see that the lamp is shining. Okay, please do the same, guys. Can you do the same, please? So can you try to do the same? Do you have the same or not? Please tell me if it is like possible to do. So now, if we have a look into this place, it would be interesting that we would have made it so the lamp is blinking. So in order to make it blink, we need to understand one thing, that here in this microcontroller, you have a clock. And you know what, in each computer you have a clock, and the clock means that all the time you have the stream of a signal. And you know that if we just, let me explain a little bit. So if we have the clock, it means that there is a flow of signals. There is a flow of signals, and you can have the signals as the following. For example, this is the low signal, and this is the higher signal. So it means like, no, if I just try to make it like this, so this is the higher signal. No, it is the higher signal. It is the higher signal, for example, the higher signal, etc. And here is the low signal. So here you can see that it is a kind of a graph, and here you can have, for example, again low signal, and then you have higher signal here, etc. So it means that here you don't have a signal, here you have one, here you have low, and the distance between it is one clock. But you see, if you want to lamp to shine, then you can write, for example, also digital write here to blink. And I put 11, and I'll put low. So what does it mean? Then if you want to stop, if you want to run it again, then the lamp continues to shine permanently. Why it is like that? It happens because you have a very small delay between those bits. So it means that all the time you have one. If we look into the documentation of that thing, let's just look at the documentation of that thing. If I go to this Arduino Uno and you see this is the documentation, I can have a look about technical specifications of this board, and you can see that here it is basically a microcontroller, and you can have this. This is the microcontroller. This is the type of the microprocessor which is inside. And if you have a look here, there are basic characteristics like a flash memory. It can accept the program code up to 32 kilobytes. It is having the RAM of 2 kilobytes. It is having some additional instruction set into the 1 kilobyte, and it has the clock speed 16 megahertz. What is 16 megahertz? 16 megahertz means 16 megahertz. It is equal to what? This is actually 16 million hertz. And it means that it is 16 million operations per second. So something like that. If you speak about the transmission of a signal, then it is the clock, and each single bit is being transmitted. Let's say so. This amount of time, 1 second divided by 1 divided by 16 million, and this is equal, so this is amount of seconds for 1 bit to be transmitted. You understand that this is a very small time, and it means that if you have this board, so if you have higher and low, you have to make kind of delay after each of this. So you can write here delay, for example, 1000 microseconds. Microseconds, it means that it is one milliseconds. It is like 1 second now delay. And here we can also write delay, and it is 1000 again. So we can try to have a delay for this 1 second. You can transmit only the higher bit, and then during the second 1 second, you can transmit only the low bit. And then again, it goes to the loop, as you know, and then it all the time will blink. So here, we can try to make it. And this is like that. So you see, now the code is blinking. And tell me, please, is it understandable, guys? So is this understandable? How to do that? So this is the blinking code. Yes, very good. At the moment, I will show you now how to make a traffic light also. So you see, one more time, I want to repeat that here we would like to have. Okay, so here you see you have 3 of the LEDs, and you see now I can also turn them like this. If you want, you can turn them like that, and you can also have them like this. You see, and you can also turn them this way. This can be turned this way, and this can be turned this way. So here you can see that I can turn them in the different form, so I can create a nice look. And now what we have to do is we need to connect it to the board. So first of all, the cathodes shall be connected all the time to the ground, and I can make the cathodes gray. So it means that all the time these wires can be gray. I can just move and it also can be a gray color. And here, this is a gray color as well. So it is connected to the ground, yes. You can see now I can do the things like the red one will be connected to numbers 11, and I will make it red. Then the yellow one can be connected to the 12th, and I can make it yellow. And the green one can be connected to 13, and this is green. You see, so I have them like this. So here I can make, for example, pin mode. I can have a look here. Let it will be this way and that way. And I can make, so here number 11 is for output, number 12 is for output, number 13 is for output. And here I can make it number 11. Then I can make here number 12, and here number 13. And if you see, now we can try to launch it, and you can see there is this, that, and this. Yeah, so here, and all the time. But actually, this is like how it works. But you know, sometimes the traffic light goes also that from green it goes again to yellow, and then it goes again for that. So this is how we can do that. Okay, and now I want you to show one more light, which is RGB. So the RGB light is quite interesting because you can have different basically colors from there. And let's just have a look in the RGB light. So I will delete this code. I'll delete this code. I'll delete the code. And let me introduce the RGB light. So here we need to put it here, and we have the not this LED but RGB LED. You can see this is a special LED which has also the common pin. Could be the anode or the cathode type, so you can choose between that. So you can always choose the anode. But now let's just read about documentation, because if you want to work with different objects here, you need to read the documentation. And here, if you press that, you can open the LED lamp, which is RGB. And here you can see that you have 4 pins, and you know RGB is a red, green, blue, so you can have red, green, blue intensity to introduce all the colors possible by these 3 colors. And here you have the common pin. So the common pin by default is anode, it's positive, but we can change it to the cathode, to the cathode. Yes, so this is important. So here you can see the common pin. So if you want to change the common pin like cathode to anode, so you can have like that. So the common pin will be cathode. So, and it will be negative. Yes, so here if you put the negative pin, so let us try to see, for example, if you have a cathode here, for example, for the ground, and this stands for red, so we can try to connect it to 11. So it's not a good connection, so we can delete it. So and I can make it nicer. So here we can have 11. So let's just try to see. I can try to make it like this: pin mode 11 output. And here we can write digital, right? 11 higher. So let us do like this. Does it work? Let me check. You see, it works. It makes basically it makes basically the red color. You see, but if you want to have, for example, now if you want to stop, you can do like that part, and you can make 9. So if you want to add one more, like 9, so we can create 9 as high, and you can see then it's going to be green. But what happens if you want to make like digital write? And here 11 and high. So look what will happen. You have yellow. Why you have yellow? Because you have red and green. And you see red and green together gives you yellow. Do you see that? You can have different colors. But the fact it is interesting how to get all the different colors because you have LEDs, so you have to find out how to get. So let us read more documentation and then we will understand it. So here you can see simulator examples, and you can see soft pulsating and different things. There are examples how to do that, and there is you can have like the common anode, the common cathode. So I will take the common cathode, and you can see this one. So here you can get an example like that. You can see here it's very interestingly said. So here you can have this one, and here you can have basically the special kind of things which allows you to say, look what will happen if you just start the simulation. You can see that you can move this one. This stands for blue, and you can see that it makes a blue color. If you make it like this, it is making a green color, and if you're making it like this, it is making a red color. But if you just move it like this, you can vary different colors, and you can see there are like you can see you can vary different colors, and you can make the colors absolutely different. So this is like what is interesting for these LEDs. And you can see here you can have a much more interesting tag, so that you can have a kind of a thing like here you have different constants. You basically introduce here that you join these constants to RGB. You see, so here this and this they are told here is especially to understand what color is activated, but they are taking to the different colors, and here you have this ground. So basically like we did before with you. But what is interesting again, that you are making here a kind of potentiometer, and you can see that here you are making a special thing with the analog, right? And you just you just create. You see here this one to the ground, and this one you can create to the voltage in and to the things there, and you can get basically the different voltage. So it means that you will be having different intensity of the green. So it's like dimmable LED you can introduce. So this is like a potentiometer. And we can try to introduce the same potentiometer. And then you can see here, there is a very interesting thing that it returns you different thing. Like when you have the potentiometer, you can get the value which makes a kind of a signal less intense or larger intense. And then what you do, we can try to introduce the potentiometer in our project, and we can try to see how it works. So here, if you have the LED, you can see here we have the potentiometer. We can try to switch on the potentiometer, and we can try to find what is the way here. And this is the potentiometer. So we can try to understand how it works. It's a linear potentiometer, and you can get the different ways. How fast is that? How here is the kind of potentiometer parameter, and we have to understand how it works. Here is like we don't have a lot of information about this. You can try to have the potentiometer docs. Here we have slide potentiometer. We can have slide potentiometer, but we have potentiometer docs. We have something like that, and you can see that basically here we don't have a lot of the things. Okay, so let me then introduce it, and I will show you how to do that. So here you can see that we have two of the greens. So here I can make this one is the green, and this was the red color. So you just make it with the red color so that you see that this is responsible for red. And now here we need to remember that if we look into the potentiometer, you can see that you can get all this output and input. So we have to introduce the potentiometer. So let us make it let us introduce the potentiometer as well here, and we will try to make only with the different colors. But before that, I would like to join blue color as well to the number 8. So this will be blue. And here I will write also pin mode for the blue. And here I will write, you see, if I put here blue color, so it's 8. So what will happen if I try, it will be white color, you can see. So sorry, the server is busy. Sometimes it is happening. You see, this is white because all the lamps shine together. But okay, so now let me introduce I will just, well, this one says how to activate it, but I will introduce the potentiometer. So let me have a potentiometer here. Yeah, this is the slide potentiometer. So we can make it like that. I can rotate it a little bit. So here is the slide potentiometer. And okay, I cannot rotate it, but I will make it like this here. And you can see that if you want to connect, what you have to do is that this is the ground, and these are the different things. So we can try to see what kind of things are here. So this is for the ground, this is for voltage, and this is for signature. So here I can do the following. I have to connect this one to the ground. So let me go to the ground and connect it to the ground. So this one is connected to the ground. Now I can see that I can move this part here, and I will put it here as well. So here no, okay, so let it be like this here. Uh, now this part I will connect to the voltage. So it means that I need to connect it to the voltage, and I need to do that here like this, voltage in. Yeah, so this is the voltage in. And now you can see I will, if we have this, you see here we have the voltage in, but now we have to connect it for different kind of devices here. We have to make the input there. And here I will put this one for the, you see, I can put it also only for that part. So I can put it to A0. So this is one thing, and it will be responsible for the red color. So I will make it for the red color as well. So this will be for the red color. And this one for the voltage, I will put maybe this part. So now I will move this LED so that you can see clearly how it works. Now look what will happen. So here I have 411, I have the color for red. So now I will not use those things. I will comment. This one I will comment if I start doing it. So basically what I have, let me compile. It is, you have to wait sometimes because it is, the server is busy. If it was, the server is busy. Okay. Yeah, but here we need to write. Let's just write some programs because now it will not work. You see here, what is important? You have to create the function which you have analog read from potentiometer. So this one is the thing that you can create. Basically, you see analog write to this one, and you have here how to say, you can try intensity of the color. If you want to put intensity of the color, then you need to write it from 0 to 255. And a potentiometer itself reads from one single 10 bits, so you can have from 0 to 200, 123, 1023. But if you want to put some kind of value into the spin, then you need to change it to the same one. And you can see here, if you have this function, we can just put this function into our case. You can see it's a read potentiometer, so it means that you have to insert the pin number, and then it will return you the value from 0 to 255, depending on where it is. Here it is 0, but if you move it, for example, you move the slider to this place, it will be 255. So basically, a potentiometer just gives you the gradation, what kind of value you can receive for that. And now look, if you have it here, you have analog write, you have to have analog write, and you have the red color, so you just need to put this one, and let's just try to have this as well here. So we will not have digital write anymore, but we will have analog write, and here we have pin red, so you can see where do we put the pin red. It is the red color here, but we have the pin red. And now we will make it like potentiometer red. So here, what we do, we just have analog write, we just have a pin red, it will be 11. Yes, so we have 11. So this is for red color, you can see. And now here we have A0. So because here we have the pin of A0, which is for potentiometer. I hope you understand. So here analog with the potentiometer. And then if we start, let's try to start. So we have to compile. And you can see now I do the same. So I can change the intensity. So I'm just changing the intensity, and it is like dimmable color. So it means that you are making the dimmable color, and here is the different intensity. Is it understandable, guys, or do you need more explanation? So basically, you don't need this part anymore, because and now you can see that what you need is just you write the analog, right? And here you need to have you need to map this color. So here you need the function for this potentiometer. So you just take the value for the potentiometer. So you have these ones, yes, and you just transfer it to that place. Is it understandable? Yeah. Okay. How is it, guys? So is this clear or not clear, or maybe it is like a little bit more difficult? What can you tell about it? Well, the thing is that now you can see that you can easily connect the potentiometer, and I can do like I will give you a little task and afterwards what you have to do. But now we can connect two potentiometers, so we can close here. We can have one more potentiometer, and we will make it once again. So here, look, I just put it here. One moment, we need to go for the next potentiometer. We can try, for example, this part. This is also a nice one. And this potentiometer has absolutely the same thing. You have ground, SIG, and VCC. So I will use this one for making the green color. You can see here, if you have a ground, then you need to join to the ground. And this one will be joining the ground here. So I did it for this one. Now here we have SIG. So this is for, and here, firstly, we'll come to voltage, and we'll have voltage in. So the voltage is inside. And now we have this button, which is change of the signal. So you can just go for this one. And this is responsible for green. I will put it to A0. So now I can write this color. So you can see here, I can create the color for green is responsible is 9. You can see this, I think it's 9. Yes, it's 9. So not 8, but 9. And here you will have not A0, but A1. And this is basically all what we need to change. And look what will happen. Now we have this one as shine. So now I will just close this and I will open this part, and you can see it makes a green. You can see here, so you can turn around and you can change the intensity of green. And now if you change the intensity of light, you can make different colors. You can have like yellow one. Is this understandable? And now you can see that you can use this potentiometer or that potentiometer, and this is not, this is what we have. Now I will attach another one, and then I'll give you the task. So here I will attach one more to the blue color. So it is the same. So you see, this is important that you have the function here, because you can change the pin, analog to each pin. So otherwise, if you don't have this function, then you have to write for each of them, you have to use the mapping. Because why you have the mapping here? This is important, because if you introduce the potentiometer, it has, when you just turn the knob, or if you just move the slider, then the values of the signal change from 0 to 1023. But you need to map them to a different thing, like from 0 to 255, because in LED it understands basically the signal from 0 to 255, as it is like the digital signal for intensity of the green, white, blue, or red color. So what we do here is I will introduce one more potentiometer. So here I can use the potentiometer also. Where is it? Slide potentiometer we can use, or maybe we can use the knob again. So here, this one, it's like too big. We can use the knob. Knob is better. Yeah, like that. And you can see that here we also need to have ground. Then we have to have for another SIG. So I will take A2. And I will have the voltage. So voltage, it needs to be the voltage there. So the voltage shall be as well here, voltage in. and the voltage will be the brown color, and this color shall be blue because it is responsible for the blue color. Now, if we want to have the blue color, so we have to do the same with the analog write, and you can do this here. Here you can put 8, and here you can put 8 too. And you can see that here we need to define also these ones for output. They are not divided for output. And here you can see I defined this one for input. Then here they divided for input So we didn't define this for input, but they are defined for input by default. So basically I can define it also for input because it would be correct. So pin mode, for example, A0 is defined for input, and the pin mode 8.1 is also defined for input, and the pin mode A2 is also defined for input. So this is important. And now we can try to launch the program, and you can see now you can intense the blue color. You can see the blue color is also intensified. So here you can say the blue color, and now you can make the cyan. You can make also some kind of other things. So this is how it works. So then you can do in different colors. No, it is not like going too fast, but I hope you understand it. So this is how you can attach RGB LED, and I want you to go through this. And for you, maybe it will require some time to understand these principles. And what I need to do, you have the next lecture, you have to practice. And please do the thing. I will create the task. You have to do it yourself and record the video explaining how it works and then upload it to the exercise. Okay? So then let me make it.